We place our pet ant Clyde on a mass or on a string. So let's make a string.
Mm-hmm.
All right, and then we need an ant. So let's put our pet. Ants are usually red. All right, and Clyde has a mass little m on top of the horizontal stretch rope where he holds on tightly. The rope has a mass of big M and a length of L under tension F. You start a sinusoidal transverse wave of wavelength lambda, amplitude A, portion propagating along the rope. Motion of the rope is in a vertical plane. Clyde's mass is so small that his presence will not affect the propagation of the wave. Question A is, what is Clyde's top speed? It says Clyde enjoys the ride and begs for more. Not sure how an ant's talking to you. That's kind of scary, physicist person. You decide to double his top speed by changing the tension while keeping the wavelength and amplitude the same. Should the tension be increased or decreased by what factor? Any ideas?
Okay. Top speed, so you're looking for Vmax. So your Vmax is equal to Vmax here.
How do we find velocity in general calculus sense?
Taking the derivative of the position.
Good. So, what is the position formula? We're talking about
transverse wave.
Right?
Mm-hmm.
Okay, so what is the velocity in relation to this? If this is the position, the velocity is going to just be the derivative of that, wouldn't it?
Mm-hmm.
Okay. And we're going to be doing it with respect to okay, so looking at that, what would the maximal speed be? Well, what's sine's maximal value?
It's 1.
Yeah, because this is maximal value is 1. Vy max should be...
So be A omega.
A omega. What is omega also equal?
It's equal to K square root of K over M? Is that it?
How about 2 pi f?
Oh, that one.
Okay. So then we can write Vy max equals A.
2 pi f.
What else does velocity equal?
Equals.
Right?
Sine.
Are you with me or not?
Yes.
Okay. Then we can solve for frequency. Okay. There's also V equals the square root of force over mu.
Mm-hmm.
What is mu equal to?
That's equal to...
Linear mass density mu is going to be equal to the mass over the length. Still with me?
Mm-hmm.
Okay. So now, what can we do? Let's see. How about we plug in that V formula in for the V right there? What would that give me?
Then that'd be F is equal to square root of...
So then the last thing we got to do is plug in what our frequency is into this equation. Which of these things can we actually change? Can we change the mass of the rope?
No, you can change
Force.
force.
That's about the only thing you can change, right?
Yeah.
So what do we do with that force? So what would we need to do the force to increase the factor of that whole equation by 2? Right? Because force is under the square root, so what would we need to do the force? So the force is going to be becoming something, some multiple of force, right? Some number times force would go right there. And the question is, what does this number need to be for us to bring a factor
4.
2 out? It would need to be a 4, right?
Mm-hmm.
Do you see it?
Yep.
All right. Do you have any questions on that? So we started with the formula for position. We derived it to get velocity. Then we also remembered that velocity was equal to a few other things. In this case, the force over the linear mass density here. And we plugged that into there so that we could get what frequency was in terms of the force.
Mm-hmm.
Once we did that, we were able to plug in that frequency into our Y or max equation right here.
Yep.
That frequency.